Hello, so this is the very basic form of biasing circuit for the BJT, that is the bipolar junction transistor. So what we see, this circuit is called as fixed bias or base bias circuit. We call it as a base bias circuit or fixed bias circuit because we use the fixed values of the resistor RB and RC to set the DC operating point or Q point of this circuit. Let us see how. So we see that there is a supply voltage here, and to the input side of the circuit we can apply the Kirchhoff's voltage law to determine various currents and the voltages. So the KVL would be VCC minus IBRB minus VBE equal to 0. So there is a voltage drop across this value of resistor RB. Similarly, we can set Kirchhoff's voltage law or KVL in the output side of the circuit to know the values of currents and the voltages. So it would be VCC minus ICRC minus VCE equal to 0. So here is the voltage drop across this resistor RC. Since these two resistors are used to draw the currents from the supply VCC, we are able to set the currents in the circuit. Those currents are IB and IC. So the value of RB can be written as IB would be equal to, from the Kirchhoff's voltage law, VCC minus VBE divided by RB. So this would be set the value of IB. Since IB and IC are related with this equation, IC is given as beta multiplied by IB. So we know that the beta is the current gain of a transistor. Multiply it with the value of IB, you get the value of IC. Similarly, you can calculate the value of output voltage VCE. Now we know that the base emitter junction is forward bias and the collector emitter junction is reverse bias. The collector base junction is reverse bias. That sets the operating point of the transistor, and transistor operates in an active region. After understanding the basic working principle of this fixed bias circuit or base bias circuit, let us focus on what would be the drawback of this circuit. So there are two drawbacks. The first one, when the temperature rises, let's say this circuit is operating not at the room temperature but at a higher temperature. Because of that, the collector current will go up. Since the collector current is related to the base current of the transistor with the equation as shown, which is beta times IB, and the IB would therefore be IC divided by the beta. So if the collector current rises, the base current is also rising because of the transistor equation. So due to rise in IC and the IB, the earlier set operating point is no longer active and the transistor is experiencing a new operating point. So we see that the stability of the circuit is changing due to different operating point. Second factor is the beta itself, which is the current gain of the transistor. So let's say the transistor as shown in the circuit has a certain value of beta. If this transistor is changed, it will have another beta. So different beta will also cause a different operating points of the circuit, which will ultimately affect the stability of the circuit, and the circuit will not function as expected. The currents and voltages will always vary with respect to change in beta or with respect to change in temperatures, which is affecting the stability. To circumvent these problems of stability due to temperature and the beta, there are some modifications of the circuit, such as placing the emitter resistor in the emitter path of this circuit, which we have explained in another video. So do check out that video. If you like this video, share it with others.